Hi, everyone. Welcome to the Research Showcase. My name is Kinneret Gordon, and I'm the lead research community officer on the WMF research team. Welcome to this month's Research Showcase, the last one of 2024. Research Showcases are monthly convenings organized by our team to recognize and share recent research on or relevant to the Wikimedia projects. For those of you joining us live, we welcome you, as always, to ask questions of the speakers in the chat, and we will monitor this channel and pass the questions to the speakers at the end of each of their presentations. And as always, we kindly ask that attendees follow the friendly space policy and the Universal Code of Conduct. We don't have any special announcements today, as we usually do at the start of the showcases. So without further ado, let's dive right in. I'll now pass it to Leila Zia, my colleague, who will introduce and host today's showcase, and will also tell us a bit more about the theme and the speakers.
Cool. Thank you so much, Kinneret. Hi, everyone. My name is Leila Zia. I'm the head of research here at the Wikimedia Foundation, and I am honored to host this month's research showcase. It's our last research showcase of the year. It's usually a special one before we wrap up 2024, and I'm really looking forward to the theme, to the conversations that we're going to be having together in the next 75 minutes or so. The topic is, of course, especially close to our hearts, both in the Wikimedia Foundation and also within the Wikimedia community and also the research community. AI for Wikipedia is a topic that we have spent substantial amount of time thinking about and doing research on over the past couple of years, again, within the Wikimedia Foundation and also outside of Wikimedia Foundation. The recent advancements in AI provide significant amount of opportunities for the projects and also risks. This has been something that we have been talking about over the past couple of years in variety of venues in different ways. What is incredible with these recent advancements on AI is that we can reduce the cost for some of the activities that the editors are doing on the projects or make the projects more accessible for readers. We're going to hear from two scholars in this space and the work that they have done and their labs are doing in this space to learn more. At the same time, the recent advancements have reduced the cost of content creation, while we have not exactly figured out how we're going to support in detail editors for reducing the cost of verifiability for editors. So in Wikimedia Foundation, we are spending a lot of time and resources thinking about how we can support editors for reducing the cost of verifiability as the cost of content creation has significantly decreased. We're going to hear from Bob West and Monica Lam shortly, and I'm going to introduce them. I'm really looking forward to this conversation as both researchers are doing significant amount of work in the space of AI and particularly AI for Wikipedia. With that, I'm going to introduce each of them. Dr. Robert West is an associate professor at EPFL, where he heads the data science lab. Bob has been a Wikimedia Foundation Research Fellow since 2017 and has been with our team since 2015, working on different projects on Wikipedia. He's currently a visiting scholar, a visiting researcher at Microsoft Research. His work focuses on AI, NLP, and computational social science, often in the context of Wikimedia projects. Dr. Monica Lam is the Kleiner Perkins Mayfield Sequoia Capital Professor in the School of Engineering at Stanford University. She serves as the faculty director of the Stanford Open Virtual Assistant Laboratory. She is a member of the National Academy of Engineering and an ACM Fellow. Professor Lam is also a co-author of Dragon Book, the definitive text on compiler technology. She has received numerous Best Paper awards and was recently awarded the WMF Ray Award of 2024 for developing sets of technologies that can mitigate and eliminate hallucinations in large language models. Each of our speakers will have roughly 30 minutes in which they present roughly 20 to 25 minutes, and we will follow each presentation by a Q&A. Towards the end of the showcase, we're going to have a comment time available where both of our speakers will come together and we're going to have a conversation led by your questions. If you have questions for the speakers and you're joining us from YouTube, please put your questions in there, and my colleague Eli will relay your questions in the virtual room we're all in. If you're in the room, you can raise your hand and ask questions when there's time for a Q&A. With that, welcome Bob, and welcome Monica. It's great to have you here. We're honored to host you. And Bob, please go ahead with your presentation.
Thanks so much. So first, check, can you see my slides? Okay, excellent.
Yes.
Okay, yeah, thanks so much for the kind introduction. It's a great honor to be here for the special Christmas edition. So I'm really looking forward to being here. Okay, so I pretty much owe my career to Wikipedia. My very first paper ever back in 2019 was about leveraging Wikipedia games to compute semantic relatedness. And still today, 15 years later, Wikipedia is still a key ingredient in my lab's research portfolio. Looking back at my 15 years of developing machine learning and data mining methods for maintaining and improving Wikipedia's content, I get a weird feeling that probably several among you in the audience have experienced as well. I'm wondering, with LLMs on the block, was all of this in vain? Are the methods that we've developed still relevant today? But it's probably better for our mental health if we think of LLMs not as destroyers of what we've already done, but rather as enablers for stuff that we've always wanted to do. So the silver lining that I see is this: LLMs give us a big new power. Before LLMs, the big wrenches in our machine learning toolbox were classification and retrieval and ranking of old stuff, old texts and images that already existed. LLMs, on the contrary, allow us to generate new stuff, new text, new images, and so on, new knowledge that have never existed before. These newly gained generative powers allow us for tackling old problems in new ways and also for attacking new problems that were entirely beyond reach before. In this talk, I will start by giving you examples of both kinds of projects. One project where we use LLMs in a new angle to attack an old problem, and then another project where we use LLMs to tackle a new problem that wasn't feasible before LLMs. I won't go into the technical details since they're not the key thing that I want to get across, and those technical details are also available in the papers. Rather, I'd like to highlight the work that we did in order to make our methods actually useful in the real world. I call this part from preprints to postprints, because it's about the work that happened after we published the papers. So yes, it turns out you can write papers without showing that your methods actually work in the real world. And then finally, I'd like to dream a bit what might be possible in the Wikiverse if we were to train or tune our own foundation models, Wikimedia Foundation models. Overall, the goal of the structure of this talk is to, in the first part, show seeds of promise, shy first attempts of harnessing LLMs for improving Wikipedia. Then I'll share lessons learned about obstacles that make it hard to go from prototypes to products. And then finally, I want to dream about what's possible if we overcome those obstacles. So the first project that I will talk about is an example of a problem that's been around for a long time, information extraction, but for which LLMs offer a new angle. So let's dive in. Consider the following example of what we'd like to be able to do with information extraction. Given the text, John Smith played the part of James Earp in the film Wichita, we'd like to extract, among several others, this subject-predicate-object triple. where we have these identifiers, which are the keys of entities and relationships in the Wikidata knowledge base. So this triple, John Smith actor, comma, performer, comma, Wichita 1955 film, represents one of several facts that are expressed in the input text. Why is this information extraction task hard? It's hard because entity and relationship names are often ambiguous. For example, John Smith could be an actor or an astronomer, or probably hundreds of other people in Wikidata. Similarly, Wichita could be a city in Kansas, or it could be a movie, or many other things. Why does this task matter in practice? It matters because information extraction is really a key task in data science. If we can extract structured information from raw text, we essentially step from a messy world into a clean world. Imagine, for example, that you could extract all facts mentioned across all of Wikipedia in all languages and represent them in this triple form. That would be amazing because then it would be much easier to discover inconsistencies across articles and inconsistencies across languages, and this way would be easier to keep Wikipedia up to date. Previous solutions for information extraction consisted of these pipeline systems with multiple stages, such as named entity recognition, named entity disambiguation, relation classification. These systems take text as input, and they return triples of numeric knowledge base IDs as output. One problem with this approach is that errors accumulate along the pipeline. If you make an error early on, it will percolate through. On the contrary, our solution called Generative Information Extraction, or GINI, this is a project that was led by my student Martin Józsefowski. Our solution treats information extraction radically different as a sequence-to-sequence text generation task that's actually doable with LLMs. So here the paradigm is text in, text out, which is quite different from previous methods where the paradigm was text in, numeric triples out. So the twist is that the output text must follow a specific format as shown on this slide, where you have a valid entity name, comma, a valid relation name, comma, and then again a valid entity name. But it's still, this output is still generated as a text string consisting of words or tokens and not of numeric knowledge base IDs. So this way, by construction, all entity and relationship names in Wikidata are already unique. They're unique because where necessary, they contain these disambiguating terms in parentheses, like actor or 1955 film. And this way, by generating only valid entity and relationship names, you for free. Another big plus of this approach is that the language model knows so much about the world from pre-training, including common sense, and it can leverage all that knowledge when extracting facts. And this is why at the time of release, which is already some time back, GINI actually achieved state-of-the-art on information extraction. Okay, so let's move on to example project number 2, which is about generating short article descriptions. Whereas information extraction from the previous slide was a well-established problem, generating short article descriptions hadn't been attempted before, since it was too hard before LLMs came along. So what was this project about? Wikipedia's guidelines require that each article should be annotated with a so-called short description. That's a short phrase that should indicate concisely what the article is about. For example, the English short description of the article about beer is alcoholic drink made from fermented cereal grains. So here are some short descriptions are all over Wikipedia. Here are some use cases of short descriptions from the Wikipedia mobile app, where these short descriptions are used, for example, to summarize an article's topic at the top of the page, just underneath the title. And they're also used to annotate links in the read more section at the bottom of the page. And they are used to disambiguate search results when you type a search query in the app. So we've developed a model called Descartes. That's short for describer of articles, a model for generating a short description for a given article by summarizing the article text plus some other information into one concise phrase. So here is a shout out to Maria Shakota, a student of mine who led this project. I'll spare you the technical details. All I'm going to say is that on the inside, Descartes leverages a large language model, in this case, multilingual BART, that we fine-tuned for our task. Since the underlying language model is multilingual, we can generate short descriptions in dozens of languages without training a new model for every language. And here's what original gangster Descartes would probably say if he was aware of this project. So Descartes achieved state-of-the-art on the short description generation task, which, to be honest, was rather easy since no one had attempted to tackle the task before us. But that's not because the task doesn't matter. It's it does matter. It's rather because before LLMs, we didn't have tools that were powerful enough to do a good job at this task. So next, I'd like to talk about two lessons that we learned during the two projects that I just described. The first lesson comes from the first example project that I showed you, GINI, Generative Information Extraction, our LLM-based information extraction method. So what we found in our evaluation was that GINI far surpassed prior state-of-the-art methods on benchmark data. In particular, it was much more sample efficient. For example, where prior methods needed 16,000 data points to achieve a certain level of performance, GINI achieved the same performance with only 64 training examples. That's because GINI is a pre-trained language model, so it can exploit all this knowledge that it already knows before we even start training for the task. That way it's much more data efficient. And then we showed that you can further improve performance by training on synthetic data that you can generate from a very large language model, such as GPT 3.5 or GPT-4. It's kind of a neat data generation trick. We call it Synthy. The paper is cited below, so you should check it out if you're interested. So where's the catch? The catch is that these results were obtained on benchmark data. To train and evaluate this method, you need text paragraphs with ground truth annotations of subject, predicate, object, fact triples that are actually mentioned in the given text paragraph. The folks who created the benchmark, called Rebel, used only lead sections of Wikipedia articles for generating the data, out of convenience, since those sections are easier to annotate with automated heuristics. But lead sections look very different from random Wikipedia text. And it turns out that if you train a model on lead sections, it actually won't work very well on the rest of Wikipedia articles. That's a bummer, since it means our model isn't suitable for exhaustively extracting all the facts mentioned in all of Wikipedia across all the languages, which was really the dream that we originally started from. So the lesson that I draw from this is that a state-of-the-art model isn't automatically also useful in practice. Getting good models requires good data, and that's often the hard part. As a side note, we're currently working on methods for generating better data, also with language models. We're basically trying to prompt language models to make text dirty as real Wikipedia. And that's not so easy. Okay, so in the case of Descartes, our method for short description generation, things were a bit different. Here, we are actually quite certain that our model is useful in practice for the intended use case. And we're so certain because we ran a human evaluation which showed that the automatic short article descriptions are indistinguishably good from human-generated ones. So here we went to our friends at Wikimedia and we said, look, Wikimedia, this is great. Let's roll this out as a feature. But they said, not so fast, hold your horses, we have a few questions. And so we started discussing and we discussed what it would take to bring our prototype into production. And many to-dos came up. For example, would real Wikipedians agree with the mTurkers that we had evaluate our system? What would a UI look like for presenting our automated descriptions to actual Wikipedians who would then say yes or no? Is this good? How big is your model? Can we actually run it in production on the machines that we have? How much memory do you need? Do you need GPUs for inference, or can you do it on CPUs? How many beams do you need for beam search? Is the model biased? Is it biased? Is it safe? And so on. So we still believed in the usefulness of Descartes after having all these discussions. So we teamed up with the Wikimedia Android team and we built a short description generation system that could in principle be run in production. We did a user test with real Wikipedia users, and we did show that Descartes' descriptions are indeed as good as human-generated ones, similar to what we found in the paper. But we're still not in production. I guess good things take time. So the lesson that I'm drawing here is that even if you have a state-of-the-art model, and even if that model is useful in practice and you've shown it, then that doesn't necessarily mean that it's already ready for use in production. There are still many, many things that need to be done. Okay, so in the final part of my talk, I'd like to share some thoughts on Wikimedia in the age of LLMs. And I'd like to propose a grand challenge that I think we should all work on together. Back in summer 2023, a year and a half ago, I gave a keynote at the ICWSM conference, which I concluded by musing a bit about the future of Wikipedia, asking questions like, what might Wikipedia in the end have been only a stepping stone, a transient phase towards something bigger? Is Wikipedia eventually just a large human-generated data set for teaching AI how encyclopedic knowledge should be structured and presented? But now that the AI has internalized Wikipedia's patterns, Wikipedia itself can be discarded, just as you discard the original plaster statue once you've taken a mold, so you can make the real deal, the bronze statue. I'm much less pessimistic today, actually. So today, 1.5 years later, I'd like to revisit this question and make a proposal for a symbiosis between AI and Wikipedia rather than a hostile takeover. So the goal is to spark a conversation about how Wikimedia could productively leverage LLMs while staying true to its mission. And here's an analogy that I'd like to make. Car companies such as Volkswagen, but many others too, are currently reorienting themselves as mobility enablers rather than only combustion engine car makers. So today their portfolio includes e-vehicles, software, ride-sharing platforms, etc. So to me, this seems like a good move because without reorienting, the companies would go bust. But with reorienting, the company's value proposition still makes sense. Cars are one means to be mobile, and by enabling mobility more broadly, the companies can still draw on decades of experience. Similarly, I'd argue that Wikipedia should not define itself as a community of volunteers that read up on topics and then transform their knowledge into markup text, but rather Wikipedia's mission more broadly, and this is in my own words as I see it, is to enable the sharing of vetted knowledge. Reading up on topics and then manually typing markup is one means of achieving this mission, but the mission is broader. Manual markup typing is the analog of the combustion engine. If we stick to it without reorienting ourselves, we'll go bust because AI is in the room. If, however, we reoriented ourselves by embracing AI and LLMs, Wikipedia's value proposition to enable the sharing of vetted knowledge still makes a lot of sense. I believe the best way to enable the sharing of vetted knowledge today is to embrace AI and to find productive and safe ways of human-AI collaboration. Wikipedia is already fundamentally about collaboration. So why not add a super capable AI model as yet another collaborator? So my vision here is a Wikimedia Foundation model. I think that such a model can be built to really breathe the spirit of Wikimedia. The model should be aware of the values of Wikimedia volunteers, the community. It should really know what it's all about. The model should be a generalist model that's suitable out of the box for any wiki task. It should be efficiently tunable to specific tasks if need be. If we really want a specialized model that is really good at one specific task. Such a model should always be up to date. It should have access to live content and to backend databases and so on. And such a model should be useful both for batch tasks like correct the spelling in these 10,000 articles, but also interactive dialogue with human users. As one example of interactive dialogue, I'd love to see something like a wiki copilot. GitHub, for example, has a copilot for code writing, which is massively boosting programmer productivity. And Microsoft, which owns GitHub, is now going all in on Copilot, bringing it basically to all its products like Office. I believe we could also see massive gains in productivity in Wikimedia projects from a wiki copilot that supports human volunteers in what they want to do. Here's an example scenario. Imagine that I'm editing an article and I always have in the editor, I have this this chat bar where I can talk to the co-pilot. And as I'm typing something, I say, I'm not sure if this edit is actually okay. And then the co-pilot might say, let me check the talk pages and the guidelines for you and give you a summary of what I found. And then I go on and I finish my edit. And then afterwards, I might say, oh, that felt good. Could similar articles need my help as well? And then the co-pilot could look and browse in the list of tasks that are open. What are things that are similar to what I just did and that still need to be done? And there is way more that could happen. You could imagine automating rote tasks like formatting, spell checking. Why should I do that myself if the AI can make good proposals for me and I just check them off, basically? It could help with fact checking. Give me the facts and I verify them, you know, as the humans before they go into the article, but I don't have to spend all the time doing all the nitty-gritty stuff. A co-pilot could serve data from databases in digestible form. It could write SQL queries, send them off to the database, and then present them to me in the results to me in natural language. It could route questions or tasks to other available users that might be online at this time and might be willing to take over. So what could the technical design of such a foundation model look like? Here's a design sketch. We should probably start from an open pre-trained foundation model, such as Olmo or Llama, rather than start something from very scratch. And then this model could be fine-tuned on a huge corpus of Wikimedia data. Then the model should be aligned with Wikimedia's values via community feedback, such as high-quality instruction tuning data, so good prompts paired with good high-quality responses. Another method for alignment that should be used is preference learning, where the model produces several candidate answers and then humans rate which one is better. It could also include techniques such as constitutional AI, which is something that was developed by Anthropic. I think a good effective model here should also be retrieval augmented. So it should have basically access to the live versions of all the articles such that it's always up to date. Those could be retrieved and then be put into the context. And I think such a foundation model should also be able to use certain tools. For example, it should be able to write SQL queries, send them off to the backend databases, get the results, and then serve them as natural language to users. Similarly, the model could formulate Sparkle queries for accessing Wikidata and then presenting the results in natural language. We could even dream of crowdsourcing-like scenarios where the model, if we trust it enough, could be able to basically form queries that then go to humans and that then we use to solve the problem at hand. Okay, so I think that all the technical components really already exist. Like there are papers about all of these bullet points. I think in academia, we have the expertise and the know-how how to use and combine those parts. What about computational resources? To be determined, but models come in many sizes, so there's definitely a good small enough starting point. So where's the catch? The catch, I think, it's all about the data. What data should such a model be fed for training? There are a few no-brainers. Definitely, it should see all the articles. It should see all the talk pages. It should see all the community guidelines, policies, how-tos, discussion boards, etc. So these data sets aren't hard to get. They're pretty much ready to use. What's much harder to get is data for turning the model into a good Wikimedian. For example, high-quality prompt answer pairs for instruction tuning, preference judgments for reinforcement learning from human feedback, explicit rules that define what good behavior on Wikimedia projects looks like, and so on. So this data is much harder to get because you can't just download a massive file and then use that. This kind of data needs to be created from scratch by a community of volunteers. I think that this is one of the big next frontiers for the Wikimedia community. To make something like this happen, important questions need to be answered that can only be answered as a community. For example, how to, and only that way can we figure out how to build the foundation model as a community. For example, what's the right grassroots governance structure? How should we decide what data to incorporate and what data to collect for training the model? How should we decide what kinds of tasks we want the model to assist humans with? What does it mean for a model to be a good Wikimedian? There are legal questions too. What base models can be used in terms of IP law? I think we should get the lawyers to figure it out right now. We can front load that. And then most importantly, how to collect quality data at scale from human volunteers. What are the incentives? How can we assure quality such that down the road, the model actually does what we would want it to do? So it's a tough nut, but I think we can do it. Academia has the technical knowledge, the know-how around LLMs, and the resources seem manageable, at least for prototypes in terms of computational resources. Still, we can't do this on our own. There's no single group that can do this on its own. We need the buy-in and the partnership from Wikimedia and from the entire community from the get-go. I don't think this kind of use-centric grassroots LLM project has been done before at that scale. So it requires breaking new ground, but I think it can be done. Thank you.
Thank you so much, Bob, for the inspiring presentation. We have a lot of engagement on YouTube, and I'm sure there are questions and comments from the room. We only also have a few minutes with you for this first part. We're going to come back to you a little bit later. So I'm going to invite Eli to maybe relay a couple of questions that have already come up in YouTube to you. And Bob, if I can ask you to keep your responses for now short, and we're going to have some time at the end that we're going to come back together.
Hi, thanks for the presentation. We have quite a bit of discussion happening on YouTube. I'll do my best to relay some of the questions that are coming in, and I do apologize in advance if we don't get to all of them. Going back a little bit earlier in your presentation, there was a question about how well would this work on sentences with multiple knowledge triplets?
That's about the information extraction task, I guess. Yeah, if you train the model with data where you have multiple knowledge triples, then it will be able to do that at test time too. So if you have the right data, it's possible out of the box.
Okay, thank you. And moving on to another question, we had an audience member wondering. They say, I wonder how these fine-tuned BART LLM solutions would fare against just cleverly prompted or agentic larger model LLMs. Would you like to comment on that?
Yeah, that's a very good question. And we've tried, at the time we developed those fine-tuned systems, the LLMs were BART and so on were the LLMs. And then the GPT-3 style came only later. So we did try that clever prompting, and it is surprisingly good. So for many tasks that we tried, you prompt GPT-4 and it blows everything else out of the water. Like you cannot it's often better than human data. So if you train a small model on human data, you will not be able to get the performance of GPT-4. That's what we often found. Still, GPT-4 style models don't cut it because they're too big, they're expensive, you can't deploy them at scale. So although they might be doing better, it's not really a solution, at least not at this point.
Okay, I might just squeeze one final one in, and then we can open up to the room as well if there's time. But there's a little bit of discussion around sort of how contributions, non-human contributions might work and look on the platform. So for example, I'll just offer this question that was asked in the chat. Do you think the contributions from AI editors and human editors should be distinguished by design? And if so, how do you imagine it will be distinguished? And I should note there's a little bit of discussion happening on the chat around, like, is there some interaction with talk pages in this regard? But maybe you can just respond sort of generally.
Right, yeah. So my answer would be yes, and I don't know. So I think ideally it would be great if we could track provenance. I don't know how that would be possible. Like there are techniques like watermarking for images, you could imagine that you can sign an image, cryptographically and make sure that this is from this source. For something like text on Wikipedia, it's different because there isn't like this one unit, right? You might get a response from the model, but then you change a few words. So you can't watermark it at the whole response level. You would somehow need to go to the token level, but then it becomes it's not clear at what point you should still call it AI generated, because if I just take one token from the AI response, then it's still my response, right? So I think it's an open question, but we should seriously think about it.
Yeah, and that's a good example of a particular challenge that arises pretty much shortly after you might lead with a design proposal.
Exactly.
Thank you so much, Eli, for relaying a few of the questions from YouTube. Bob, for keeping your answers short and sweet. We're going to switch to Monica now with her presentation and Q&A, and we're going to have some more time at the end to bring both presentations and conversations together. If you are in the room, I apologize that we didn't open it for your questions. Priority is YouTube for this conversation. We'll have some more time towards the end. And Eli and I will tag team to bring some of the questions and maybe abstract them for that last part. With that, I'm going to pass it to Monica. Floor is yours.
Hi, let me share my screen. And all right. So, well, first of all, I want to thank you for the invitation. I'm very excited to be here. We've been doing a lot of work with Wikipedia and Wikidata in the last couple of years, and I just love to have a chance to tell you about our work. And our research lab, the Open Virtual Assistant Lab, has a goal, and that is that we want to build a public AI assistant to the knowledge in the world. We call this the WWK. It's like not web, I mean www, but it's actually just the knowledge part of the World Wide Web. And this work is absolutely inspired by Wikipedia. Wikipedia is the world's encyclopedia. It's completely free to all, absolutely no ads, and it is around the world, right? I mean, we have over 300 languages, 60-some million pages, 90 million plus contributors. And it is I just cannot imagine a world without Wikipedia today. So what we are asking is, what should we look forward to in the future? Can we scale it up from just the encyclopedia part of the knowledge to a true world public library that is freely available to all? We are a quarter of a century into the 2000s, and so we want to think about what is next. And if you look at what we are today, where we are today, besides Wikipedia, Wikidata, there's the entire internet, of course. And there's some very important information that is available. One of them is news. News is really important because there's a lot of misinformation. A lot of people are getting information from their social media, and it has caused quite a lot of issues. And so the question is, libraries can usually have news, so can we include news? There's also semantic scholars, and another example, which is that there is a lot of detailed live information that is being generated in every domain. So that's, of course, the whole internet. Beyond that, there are specific data sets that are archival, that collected a lot of data, like Data Commons. It has a lot of information about, the data out there. Common Crawl, the Internet Archive. They contain the history. They include TV shows and books and so forth. And of course, there are also historical archives. A lot of them have been digitized. And even if they're not, we can digitize them. And all that in all the different languages. Now, if you imagine, a lot of these things are already available. It's like a public library, or is it? There's a huge difference between Wikipedia, Wikidata, and the rest of the data. And that is that Wikipedia and Wikidata are curated. People can make sense of it because there's just so much information out there. So the question we ask is that instead of just saying, hey, here's the web, go search it, can we actually introduce something like a public AI assistant that can help you access the data and curate the data? So besides chatting, besides searching, we can talk about chatting. It can be an interactive dialogue where you continue from, you learn and then you continue to discuss the material. And then the second one is, can we actually help curate? How can we do research with the help of the AI assistant on this large amount of data out there, and also in all languages? So what I want to talk about today is a pilot of such a public AI assistant. We just throw a first draft of this website together. It is called knowledge.org. Okay, and you can try it. It has a few, live services on there already, and we're continuing to build on top of it. So, and then you say, wait, you're using AI, but we all know that LLMs hallucinate. You cannot, you just cannot just use LLMs. And our project here is to recognize that. And we say that LLM is a basic natural language skill. It's our interface to natural language, but it is not a knowledge base. We have to rely on the library of information that I just showed you in order to get to the actual facts. And so the question is, how do we build on top of the LLM? So we turn to what people are doing in education. I mean, in education, kids learn the language and they go to school and they learn cognitive skills. And here is the Bloom's taxonomy. It's designed by educators for human learners. And it says that at the bottom is the remember level. This is what LLMs are really good at. They may get it wrong sometimes, but it's still much better than our memory. So above that, you have to learn to understand, to apply, to analyze, evaluate, and create. Create doesn't mean creative writing. It is what research assistants do, which is that they learn, or researchers do. They learn from the literature, and then they create new material based on what they learn. So in our lab, we are taking each of these steps, and we are building systems that learn these cognitive skills on top of LLMs. And we start with reading, writing, and then data analysis and so forth. The whole idea is that we can automate a lot of the work that the research assistant can do. So what we have created is also called Genie. That was really funny. Our project name is also Genie, and it is a research assistant with general cognitive skills, and it is applicable to any domain. The whole idea is that we're tapping into all the sources of data out there. It uses LLM as a subroutine, and you describe it, the corpus schema, you tell it where you can get the data. And so far, we have worked with the internet, the Wikipedia, Wikidata, FEC, the campaign donations data, and also a historical data set called the African Times. So these are all the different things that we have done. But the whole system that we have built can be applied to, any corpus that you have. And how do we do that? There's actually a very simple idea that we do, and that is that we simulate the human processes. It takes many steps if you use the LLMs, but we just simulate it. And we don't just give you an answer right away. We do the reading and writing and so forth in order to give you a reliable answer. So I'm going to go through how we do reading, writing, and data analysis. Okay, let's start with reading. So this is a paper we presented last year. I cannot get into the details of any of these technical, the papers that I'm going to talk about. So please go check it out. And I'm just going to give you the highlights. So the first project is about reading, and we are reading the Wikipedia. It's called, so the chat is called WikiChat. So it is based on RAG, Retrieval Augmented Generation. A lot of people are doing RAG, but a paper by Liu et al. At Stanford shows that a lot of these commercial systems still hallucinate. And they carefully analyze it, and they said it's almost like, 60% of the facts, only 60% of the facts are grounded in retrieved data. This is a little bit disturbing. And let me just explain why that can happen. And that is that when you do retrieval, the information that you collect may not answer the question. And if you tell GPT to answer the question based on the retrieval, it likes to please, and it will make up things, to give you an answer. It is the hardest thing is to get GPT to say, I don't know. So we don't do that. What we do is model how we human handle a problem like this. I don't know off the top of my head. One of the things that I would do is to search Wikipedia with a query. And then after I do, or the internet, we do a search with query, and we filter out the irrelevant information. This is what we use the LLM for. We summarize it and filter. We do not ask it to say, answer the question, because you're introducing, it's very easy to invite hallucinations. So if you filter out everything, we say, I don't know. However, today, we don't just do Wikipedia. We don't just do search. We also use LLMs. For example, you can talk to GPT and ask GPT what it thinks. But we don't just give you the answer from GPT. We dissect the set result into claims. We fact check every single claim by searching it. And in this experiment, we do it with Wikipedia. And we filtered out the incorrect claim. And then we put them together and we give you the answer. So in other words, we're doing multiple easy LLM steps, each of which has a very high reliability. And then we can sell external data. And you say, look, you're calling LLM so many times, it's expensive, it is slow. And the question is, how do we speed it up? Again, we model it after what humans do. When we play piano, it's a piece we don't know, we go really slowly, we practice a lot, we go faster. In the same way, at the beginning, we are using multiple calls to the LLM, but we try it on many inputs and outputs, and we take the result, we use it to fine tune. And now you can have a faster and smaller LLM. And it is great for confidentiality and efficiency. And this is a technique that you can reuse over and over again to learn higher level cognitive skills. So we did an experiment. This is with real users. We did many experiments, but this is the most important one. And that is that we actually have real users. They read the first sentence of a new Wikipedia page, and they carry out a conversation with our chatbot. We did 2 experiments. One is with GPT-4, and the other one is WikiChat using GPT-4 and doing RAG on Wikipedia. And we discovered that, we did the user ratings, and we actually come out higher than GPT-4 itself. And what is interesting is that when we dig into the factuality, because it is starting with a new Wikipedia page as a conversation, they are at an accuracy of about 40% and we actually got to almost like 98% in accuracy. And the ratings that the users give, they don't even know that GPT-4 is lying half of the time. Okay, so I think this is a very good test on why this is much better than chatting with GPT-4. And well, and we are very thankful that we got this Best Research Award of the Year from Wikimedia Foundation, and we kept working. So now we have WikiChat is in 25 languages. And then, what we see here is really exciting because we are breaking down the language barrier. And this has a lot of implications. One is equity and inclusion. There are many people who don't know English, and the English Wikipedia is the largest. Now they can just use their native language and get information from the English Wikipedia. So this is just one example of how it is useful. And at the same time, because we are searching and gathering information from all the different 25 languages, we're pulling the world's knowledge, and we discovered all kinds of things that we didn't know. So, for example, we asked about a Persian physician, and there's, of course, you expect that there's a lot of information in Persian in Wikipedia, or the Farsi Wikipedia and English Wikipedia and so forth. But the interesting information comes from a Japanese Wikipedia on this Persian physician, because some Japanese writer wrote about it. So the concept here is that you're breaking down the barrier, you're getting information from all the different languages all at the same time. So a question that I would like to ask is whether it makes sense to make WikiChat available on wikipedia.org, and it's a discussion I would love to have. So let's talk about writing. We have a couple of papers on this. And the idea here, and this project is called Storm. So there is a lot of information out there. If we do so one thing we can do today is that you can ask a question, you can find a search and get a few websites, and then you summarize it, but we think that that's not quite enough. If you look at a writing project, there is a pre-writing stage and then the actual writing part. The pre-writing stage, you have a topic, you have to do research, you get the references, you create an outline, and then you do the writing. So this paper focuses on the pre-writing stage. And this is what we do. We start with a topic, and then we say, what are other related topics, related papers of this topic? And we extract out the various perspectives. If you talk about the Olympics, there will be the athletes and the audience, and then the host country and so forth. From the different perspectives, we pick one at a time, and then we say, what question do we have? We then go to an expert. The expert in this case is an LLM that searches the web. It comes back with the answer, and the Wikipedia writer, for example, in this case, will read and ask questions again, and then you go back, and then you cycle this through many times. In other words, you are reading, searching, you're reading, and then you generate new questions from what you have read, and then you go deep. This is exactly the kind of thing that we normally do by hand, but now we just simulate this using LLMs. So this is one perspective, and we do that with multiple perspectives. We get the conversations, and then we try to put the outline together by using a starting point, and when we combine them, we refine the outline, and then we write the paper. So we showed this work to various people, including journalists, and they would say, look, we don't just collect information from whatever you can find. We have a point that we want to make. We want to be able to direct the research. So we say, okay, now we have to add interactivity. And the first thing you can imagine is that I'm going to add a chat. But the problem here is that people don't know what questions to ask if it is a topic that they're not familiar with. So the question is, how do you learn about the unknown unknowns? It's something I don't know, but I don't even know that I don't know, what I should learn. So what we do is that, again, we simulate a very important and common way for human to learn. And this is how I learn a lot of things, is that I listen to experts or children listening to their parents. They have a discussion, and then you hear whatever you can pick up. And occasionally, I would participate by asking something that I don't understand or something that I'm particularly interested in. So we simulate this using a bunch of experts, LLMs, talking to each other with the moderator, with the ability for the users to participate, and we generate this report. And this is the collaborative part of Storm. So what do we get out of with this process? I'll just give you an example. If you say sustainability, it takes about 3 minutes, okay? It's not quick, but it's much faster than what you can do by hand. It may fetch over 100 articles from the web, and then it generates a paper. For example, in this case, it's a 7-page paper. I can't show it here, but here's an excerpt. Everything that it says includes a citation, And it has a table of content, and also you get the full references. We don't expect people to just take this and put it and publish it. This is really just to help the humans to learn a topic quickly. And we give you the references. You're supposed to check every single reference to make sure that the LLM is doing the right job. But it is just to speed up the process for the individuals. So we have put this out. This is called storm.genie.stanford.edu. In our paper, we did a study. We invited 10 experienced Wikipedia editors to try our system, and we asked them the question, the statement, do they agree with the statement? It can be specifically helpful for my pre-writing stage, and 10 out of the 10 editors agree. And since we published the paper, we also put it out there. It is a publicly available website right now. And the updated version is about 5 months old. And we get a lot of organic users. Right now, we have about over 200,000 users from 175 countries, 350,000 articles written, and 1 million of them read. We're still working on making it easier to find articles that we are writing. And then what is interesting is that we have also released an open source, so people have downloaded it. We have 13K plus GitHub stars. And recently we have been approached by 5 school districts because students are using them in school, in their classrooms. So, we didn't quite know why we get so many users, and we discovered that there are actually a lot of people making YouTube videos for us, and they have a lot of good things, has said a lot of good things about our project. So one question I would like to discuss is, I know that there are a lot of people who requested Wikipedia pages that have not been written, and maybe the Storm can help draft those requested pages, and then we go on from there. So that's the writing. So let's talk about analyzing data. We also have a couple of papers on that. The first one is done in collaboration with Hal from Wikimedia Foundation, and we were very excited with this collaboration. So I don't think I need to explain. Of course, Wikidata is just amazing. It's the largest life knowledge graph. It is a data set used for a lot of research. And it is represented in the semantic web graph, says semantic web, and you query with SPARQL queries. And it is not easy to come up with these SPARQL queries. There are forums. There is the request a query forum that is hosted by Wikidata for people to ask questions about how to write queries. And here's an example of a query from that forum. What are the musical instruments played by people who are affiliated with the University of Washington School of Music and have been educated at UWash? And how many people play each instrument? So this is an example of a piece of some research that you might want to do. But this is complicated. And in order to answer a question like this, you have to go look at the knowledge graph. And here is a tiny little snippet of information where you see that there are people, their instruments they may play, and then they play different instruments, and they may be affiliated or educated. And now you have to put this all together into a table. And this is what a SPARQL query looks like, where we already heard a little bit about that, where you have to find the unique QIDs, the property IDs. And what you see here is the SPARQL query, and it will generate you a table like this. It's an amazing resource for researchers, but it is really hard to write that kind of query. So what we do is that, again, we simulate human experts. We tell the agent that these are possible things that you can do, includes how to do searching for information, to get the QIDs and PIDs. And then you can get the Wikipedia entry, you can execute the SPARQL, you can look at the result, and then you figure out what's wrong with it. And then you go on. You can also learn more about the property examples. We just heard about that too earlier. And so this is what we do by hand. And we just say, hey, agent, use this approach, do multiple rounds to come up with the query. So that works out pretty well, well enough for getting a SOTA result, let's put it that way. So what we did is that we put up a news data set, the Spinach data set. It is consisting of real-life complex queries. This is the first time there is such a data set. And we did this experiment. We used all the state-of-the-art results, and none of them come close to doing anything with these real complex queries. We are getting to the 46, 45% F1 scores for these complex queries. We are very happy that it is also deployed on Wikidata on the forum, on the request a query forum. And we've seen at this point, we haven't released it for that long, over 1,000 conversations. And we did some sampling, and we get to about 78%, which is actually nicer, better than the benchmark results that we have received, gotten. And in summary here is that what we have said is we're doing chatting. We have now made it truly multilingual, 25 different languages. Storm, it helps you with the free text research. We search the website. We use the Wikipedia approved web pages, by the way, because there's a lot of information we do not want to include. And it also has Semantic Scholar. And Spinach is for research on structured data. Then you would ask what happens when you have hybrid data. We actually have another project, the second paper that I referred to. We actually created a new query language. It's called SUQL, Structured and Unstructured Query Language. We translate natural language to queries in this data and in this language. This is how we search for combinations of structured and unstructured data. And we are now, work in progress is to integrate all these functionalities together to create an environment where you can chat, we can do research, structured and unstructured, and do, and hopefully this will help you with your research. So so this is all the, various papers that we have written. But since then, we have been working with real life groups. We talked about Wikidata. We are working with big local news. We put the campaign data on Night Election Hub. We work with the Center for African Studies at Stanford, and we are helping historians to work with African Times. And interestingly, our projects are used in the classroom to help the students learn how to do research and actually write interesting, like novel articles. And we're also working with ACLIT for event extraction. They extract information about conflicts all around the world in over 80 languages. So we're working with them. With Northwestern, we're working on this new project that gives you multilingual news information. We are going to start the collaboration with Internet Archives and Data Commons. So we're doing all this work, and one of the most interesting quotation that I like is from history professor Trevor Getz. He's told me, he said, I used to hate AI, now I love it because he can do so much more with the corpus. And, these are just examples. Our tool can be applied to other historical corpora and so forth. And so I'm happy to announce that we are organizing the first workshop on a public AI assistant to worldwide knowledge. We're very thankful to our sponsors, Slow Foundation and Stanford HAI. And we love the Wikimedia community, and we want to welcome you and invite you to participate in this initiative and in this workshop. And I just want to put up the concept that if we can get a free public AI assistant, it will have tremendous impact on the world, such as removing the language barrier, for creating equity in accessing knowledge. Hopefully that will increase our global understanding with the news and so forth all around us, lowering the barrier to research, and hopefully it will lead to a lot of discovery of hidden knowledge. Well, thank you for listening.
Thank you so much, Monica, for the wonderful presentation, the overview of so many work that is happening within your lab, under your leadership and the work that you and your collaborators do. This is really nice to see kind of the overview and hearing that from you. I think many folks here in the call and online have been following the work that you all have been doing, and it's great to see an overview of it in one place. There are, as usual, as is with the previous presentation, multiple conversations happening on YouTube. Eli, I wanted to ask you maybe if you can prioritize for the coming few minutes, like 3 or 4 minutes, we go to the YouTube chat and then we can come to the room and open it to questions from the room.
Yeah, thanks, Leila. I've got a couple queued up that are coming in. There continues to be a lot of interest and conversation happening on YouTube, and yeah, thanks for the great presentations today. I'll relay that as well. One person is noticing that Storm's outlines and table of contents are very different than what human editors might produce. Is this something you've noticed, and would you like to comment on that?
And what are the differences?
They haven't said specifically. They're just noticing some general differences. Is that something that's come up for you?
I don't think I'm knowledgeable enough about what you guys know. So maybe it's hard for me to comment on that.
Okay.
It is an open source and it is a continued project. We would love to hear the differences and ways in which we can improve our system.
Okay, I'll see if we can get a few more details maybe, and we can circle back to that one. There's also a little bit of discussion and questions around, I think, basically the financial costs of Storm. For example, one person was wondering what this costs on a per request basis, and then there's some discussion and question about is accounting done on a per request basis at all? Would you like to comment on that a bit?
Oh, that's an interesting question. It used to be almost $1 per query, but it is now cheaper because we are using GPT Mini, and it is amazing that it is a smaller model, faster, cheaper, and it does the work. It turns out that currently our major cost is on Bing search. It's actually this search engine and not the AI part. So, and if you look at maybe if you think of it as 50 cents or so, I would say that I would even imagine that students would rather pay for the 50 cents, get their project done instead of drinking a cup of coffee, right? So it is expensive. And of course, we are very interested in, oh, by the way, in the workshop. This workshop is about bringing the journalists and historians and telling them that this is now all possible. Jump on it, use your AI for work. And we are also inviting the philanthropy organizations and the government organizations and large companies. And hopefully we can get some kind of a support for a public library. Public library is funded usually using public resources. And I think some individuals may be able to pay for it, but there are a lot of people who can, and we would really like to be able to serve that function with basically the same goal of having why people fund public libraries. But now we have a world public library. And I think this is, if you look at what Wikipedia is doing, we are just kind of modeling what we are talking about with what we are, what we see that has been done by the Wikimedia Foundation.
Thanks, Monica. We are getting a little bit of a clarification to circle back to that last question. They're noting that just generally the Storm outlines are much lengthier and go into much more detail in their experience than they see human editors do.
The outline or the content? Which part? The table of content or the actual write-up?
The outline, yeah.
The outline is the table of content or the
table of contents.
The table of content. The table of contents is really to help with the writing stage, as opposed to help for the individual readers, if you will.
Okay. Yeah, thanks for the clarification.
Okay. And the table of content is very important for us to organize the points that we are going to make. So maybe that's the reason. I mean, you can take the table of contents and maybe abstract it a little bit if you want to show it to a reader, because it is maybe too long.
Yeah, that's a good point. All right, back to you, Leila, and questions from the room, I think, next.
Thank you so much, Eli. Yeah, and I actually want to invite, I see Isaac at least has one question from the room. I want to invite everyone in the room. Let's bring both presentations together. Bob is coming back to the screen as well. If you have any questions for Bob, Monica, either specific to their presentations or more generally inspired by their presentations. Isaac, please go ahead.
Thank you. Thank you both speakers. One of the things I really love about your work is that you're really actually building these systems that Wikipedians are using. And this is like definitely a hard challenge, and these are big projects. So I was curious to hear a little bit more from you about that process and like where are you spending the most time? What parts are the hardest? Like in my thinking, there's at least three breakdowns, right? Like one would be gathering all the right data for the given task. A second part could be like the actual model design, coming up with prompts, things like that. And a third one would be more around evaluation. But maybe there's other pieces that stick out to you as kind of, oh, this is where we spend most of our time iterating. And I'd just be curious to hear general thoughts on that.
My group is actually relatively small. If you look at WikiChat, the bulk of the work was done by, in a group with 3 students for 3 months. And this is the value of working with LLMs. They do a lot, but it was longer than we thought because there are a lot of weaknesses in LLMs, and you really have to do the experiment to identify them. So we have now learned. I think that the important thing is that we are focused on the general skills, if you are able to put that together, it just has a lot of applications without you spending a lot of time on each domain. Imagine we're doing in the past, you have to train for each domain. Here's the history or here's whatever. And now we are leveraging LLM and with this concept of high-level cognitive skills. The experiment, so for example, if you look at those 3 months, there were a lot of surprises. It's very empirical. For example, LLMs have no notion of time because it sees at training time, it sees all the data at once. So we are kind of just taking advantage of what it is good at and then fixing what we see. And I think that the process has worked out so far, which is we're very, very empirical. But it generalizes, and that's the reason why it seems to work well, even though we have a small group.
So I can also add a few thoughts. So Isaac, the 3 things that you mentioned, if I remember correctly, was compiling the data, training the model, and evaluating the model. Out of these, I would say that training the model is actually often surprisingly simple. Getting the right data is like, if it's not already there, then that is often very hard. Like, for example, in the information extraction task, that's what we're still struggling with, because you can take the benchmark data, but then that doesn't give you a useful model in practice. So now making data or collecting data that's actually like real Wikipedia data, like the data that we want to apply the model to downstream, that's been really challenging. And evaluating also is, I would say, more challenging than building the thing, because you start from such a capable model often that it's often a breeze, to get it to do something. But then figuring out how good it is takes more time, because now you have to interface with humans again, right? And you need to make sure that you're actually getting both collecting the training data and the evaluation data are difficult, because you actually have to do something. You have to collect data that's not there yet, and that's tricky. How do you know you're doing the right thing?
I cannot agree more with Bob. The whole downstream pipeline is all changed. Most of the data sets that exist are not useful, and they have errors in them. We spend more time trying, getting, we don't get very good results, and we discover our results are better than the annotated results. So this is why all the work lately that we are doing require us to work with people with real data. For example, the Wikidata queries, they come from real users. They are not synthesized. Synthesized complex queries are totally worthless. And the ACLIT project that we are doing, we are using the human, they annotated the data very, very carefully with multiple rounds of reviewers. And that's the training data that we use in order to perform something that is actually meaningful today instead of a toy benchmark. I cannot, and then we do multiple methods from automatic, we do some amount of automatic evaluation just so that we can tune and improve. And then the ultimate has to be done with real users.
Just thanks both for that. Yeah, that it's nice to hear the alignment on. Yeah, you might be able to build these systems quickly in a way that like looks okay, but then really this iteration of evaluating and fixing and everything, it does still take quite a bit of time, and that's good food for thought for us around data sets and how to maybe enable a little bit more of this as well.
And that's why this open source work is so important. We put the information out there and we invite other people to also help. And so all our work is on GitHub.
Thank you so much for that. We can take one more question from the room and then we should wrap up. Pablo.
Okay. So first, thanks to both the speakers for their impressive talk. I think it's very interesting, like all the systems that you have presented, particularly because there are AI systems that help to support humans, right? And I think this is one important motivation of the kind of work you're building, because it gives like a very positive implications of AI in an era that now there's like also like a big focus on the negative aspects of AI. And one of them is this fear about AI cannibalism, like how AI systems will deteriorate because they will start to be fed by AI generated content, right? So I'm wondering about that. I think like there are many parts of the design of the system that are already like explicitly preventing that to happen, but how you feel like your systems will need to be updated once like more AI systems are assisting editors to create knowledge. Like, do you think like the reliability of those systems will be affected, or we will have to do some interventions at the AI level, design level, or community level to prevent the reliability to go down?
So I absolutely think that there are a lot of positive impact that AI can make. And the concept here is that if you take all the information out there and you're getting children, high school students, starting to work with data, because it's now they don't have to learn SQL, right? They can now work with all the data and provide and actually create knowledge. I think that especially, LLMs are going to take away some of the more mundane jobs. And it is good for everybody, because who wants to do the mundane jobs anyway? And now you can teach, because now we're creating tools for students to use this to learn how to create knowledge, improve their way, the ability to create knowledge, and moving forward and doing more like exciting scholarly work. And I think that is I can absolutely see that will change the discussion of AI, and also the way why AI can have a very positive impact on the society. The equity part, okay, breaking down the language barrier, and if we can put resources in that, will make a huge difference.
So Pablo, my thoughts about this feedback loop are we have to first figure out how much would be good enough, because there's also a human error rate. So it would be infeasible, I think, to go for like everything has to be super correct, So that's one thing. And I think there are inklings of things that came in. I think Monica presented some really nice paths toward achieving this by having like entire workflows, right? Where instead of just relying on something that comes out of a model in one shot, you can have like basically other models that wear different hats. You know, you can have a critique model, you can have like a down-to-earth model versus, you know, like a creative model. So, and I think there's a lot of juice that can be squeezed out of these kind of multi-agent systems. They won't fix the problem, you know, forever, because especially because each of those is an AI too. But each of them can pull in like different grounding from the world, you know, brings different things, become more robust if you attack them from different angles. So I think there's a lot mileage to be had, but ultimately I don't think there will be like the solution, right? Because at the end of the day, we don't even know when humans contribute something, whether that's correct. And so how can we go beyond that? So even having a human in the loop
Evidence.
wouldn't fix it.
So I think that grounding is the key here, taking knowledge that has been vetted by reviewers, you know, all our papers are reviewed and so forth, you know, that process is still, we're taking advantage of that process. The models in terms of how we can improve it, we see that a lot of the cognitive functions are not done very well natively, and what we are working on is to look at what we have done and do some more post-training on cognitive skills. Makes it understand time better, logic thinking better, and so forth. So that's the kind of area that I would imagine doing, as opposed to expecting it to be perfectly correct with facts, because it is not a database, a knowledge base. We have those, you know, we're very good at collecting them. It's not going to memorize all the numbers. Okay, so I think that focusing on training the the LLMs with these cognitive functions, it would be an area of improvement, I think.
Thank you so much, both Bob and Monica, for presenting, for spending time with us, for having this conversation with us. Thanks also to all of our audience for asking questions, those of you in the room who are doing that. I want to just wrap up this part of the presentation and pass it on to Kinneret to close the showcase for us. I took two main themes from your presentations. If I can just like summarize that for us as we are thinking about, you know, wrapping up 2024 and looking into 2025 and what is ahead for Wikipedia and AI. One, there is, Bob, you've been talking about this foundation model, LLMs for Wikipedia and Wikimedia Foundation potentially stepping in this space more. For now, a couple of years, I think now we have done enough experimentation with fine-tuned LLMs, and this is a nice opportunity for us starting exploring that. So let's pick some of those conversations as we're going to 2025 and see like how we can make some of these more real and like talk about them and start experimenting more on these fronts. Again, on the fine-tuned LLMs, we have done quite a bit of work over the past year. And I think now is a good time to think about one or two models to rule many tasks and activities. And Monica, from your presentation, one thing that is very present for me is that we do want to use AI very selectively in places where AI is best fit to support editors for the work that they're doing. And the work that you have been talking about is like exactly in the spaces that, of course, like we care about, which is when humans decide not to spend their cognitive bandwidth on tasks that could be done more easily with machines, assisting them in those spaces. You talked about equity multiple times, and I want to underline that and say these technologies have the ability, with all of their limitations around languages, they have the ability to lower the barriers for contribution by many people across the world in their different languages, if we design with them in mind and do that from the start. So I really want to thank both of you for the work that you're doing, for the amazing work that your labs are doing. Please stay in touch. Please continue to do the great work that you're doing and let us know how we can support you. And with that, I'll pass it to Kinneret.
Thank you, Leila. And just as we're closing up, I just wanted to give a little bit of acknowledgements and thank you. So thank you everyone for joining the Research Showcase today and for the really lively discussion around these topics. I want to thank our speakers, Bob and Monica, for their contributions and their time today. The Wikimedia Research Showcase is made possible thanks to a great collaboration and coordinating team. So thank you to my colleagues, Miriam and Eli. I also want to thank Leila for hosting this specific showcase and Eli for moderating the Q&A as well. We'll see you next month, I hope, for the January showcase, in which the theme is reader attention and curiosity. Looking forward to seeing you all there, and have a great rest of 2024.
Thank you.
And we're off.